In our previous videos, we looked at data dictionaries as part of data governance. And so we're really looking at how to set up our data in terms of collection, storage, and this becomes an even bigger issue as you get to big data. So far our examples have not been that big, but we're doing that just to help simplify before we start dealing with really big data sets. So let's look at how to set up a database and the components of a database. So we're looking at relational databases. This is the storage of data tables that are related to each other. I'm just shooing my cat off the table, the newest star of all these videos here, or he's just going to push everything off the He's just going to push everything off the table. All right, so we're looking at relational databases, and our relational databases are essentially multiple like Excel spreadsheets, but we can't store all the information on one particular Excel spreadsheet. Instead, we have multiple different Excel spreadsheets we need to tie together. That is, these tables have a relationship. So we use this when we have structured data. So recall our video where we talked about structured data versus unstructured data. Recall that unstructured data are things like documents and image files, audio files. They tend to be unstructured. So we're dealing with structured data, which means this is information coming from surveys, focus groups. This is information we're collecting as part of our customer relationship or information systems. And so we have tables and tables that are related to each other. The part that my face is covering, see if I can move my face for a second, is that we're going to be using MySQL when it comes to our relational databases. So we're going to have a video where you're going to pull data from Google Cloud using MySQL. We'll talk about joins and how to use MySQL to pull information from your database. But right now, let's just talk about that database itself. Here's some examples of databases we've referenced already. So you might have a customer relationship management system that manages your interactions with current and potential customers. So this is going to have information about who's been contacted, who might be interested, how much have they bought in the past, what did they buy. So it helps you cultivate leads for future customers. It helps you with your current customers recommending new customers, and to track the interactions that you're having with those customers to improve the customer experience. You might have a supply chain management system, and so this allows you to share information with the parts of your supply chain. So you have, your suppliers who provide materials. Maybe you don't make the things, they come from factories. Maybe you buy them from wholesalers. So whoever's involved in your supply chain. Maybe you sell your stuff, it goes to a retailer or some kind of distributor. So there's many companies involved. And so sharing of information between these companies allows the supply chain to be more efficient, less waits, less back orders, making sure that the materials that the companies need are there when they need them. So you might be sharing purchase orders, sales data. You might be sharing information about, I should say, shipping, shopping. Information about shipping and logistics, so notices when things have been shipped out, so shipping notices, and other invoices across the supply chain. Ugh, gotta get better at typing. The other type of database you might have is enterprise resource planning. And enterprise resource planning, or ERP software, actually just combines the supply chain management and the customer relationship management. It's all combined into one system. So we're now integrating financial information, human resources information. So here, how many people are scheduled and when, based on what's the demand from our customers. When is the inventory coming in from our suppliers? When does it need to go out to our distributor or retailer? So it's combining logistics, movement of materials. It's combining operations information. How much is going down the production line? How much are we manufacturing? and then ties that all to how much the customers want, who wants what features. So if you think about Ford, for example, the Cam Clark Ford sells the trucks. They are tied in to Ford manufacturing. They can see how many Ford trucks are available in different towns, what models, what features are at each different location, what's coming off the production line in the next couple days. So they know when they talk to the customer that they have a blue F-150 King Ranch edition. They know exactly what's coming and when. They'll also know when there's a bunch of trucks slated to arrive at the dealership. So maybe we need extra people staff that day to prep the vehicles, take all the plastic and protective off of them and prepare them to be put on display. So we're combining all of the databases, spreadsheets, information within the organization so the information can interact with each other. And so we're combining that with our finance, accounting, our HR, our operations, our marketing and sales, all tied into each other into single databases where people have access. So when we are looking at databases, because we're taking sets of information, multiple tables, we're tying them together, it's all about the relationships between the sets of information. And so what we're going to do is create what is called an entity relationship diagram. There are different types of entity relationship diagrams. We're just going to look at one type for the purpose of this training video. There are others that you can explore on your own. An entity relationship diagram has a couple key components. First, we have a box that's going to represent a spreadsheet or table's worth of information. In that box, we're going to list all the different variables or fields that are in that spreadsheet. Now, from that list of field or variables, we need to identify the primary key. It's going to go in the top of this entity box, and it is going to be unique for each item in the table. So, for example, if we have a spreadsheet that is all about our salespeople, then the unique identifier is that each row in our table is a different salesperson. And then we might have other variables about things like when their shift is, how much sales they've done in this quarter, how many vacation days they have, whatever we're collecting. But the unique identifier there is that in that table, the one variable that has no repeats is the salesperson. Okay, so we need to find the primary key. That's the unique identifier. That's the variable that is different. There's no repetition in that particular table. And then what my head is covering up is the foreign key. So the foreign key is going to be the variable that's in the data set that also appears in some other data set, another table, another spreadsheet that's going to link the tables together. Okay, we're going to denote the foreign key with bold, okay, and we'll tie together in our visual the spreadsheets that are connected. Okay, so let's take a look at an example. All right, so in our other videos, we looked at our customer relationship management database, and we had information about the customers, we had information about the salespeople, we had information about March interactions between the customer and the salesperson, April interactions, and May interactions. So what you see here is 5 boxes. Those boxes each represent a table of data. One is a table about the customer, one's a table about the salespeople, one is about the March interactions, one's the April interactions. The primary key for each, so let's start with the customer one. The primary key here is the customer. So the name of the customer is going to be the unique identifier for that table. We can have multiple customers who have the same revenue or who have the same classification. Maybe they come from the same type of industry, maybe they're competitors. Maybe the value of the contract, how much we would, let's say, what we would charge them to build the website, that might be the same with multiple customers. But the name of the customer is the unique part here. And so you can see in our entity box, we have our primary key of the customer, we have information about the customer. These are the different fields or variables. And then we have a salesperson attached to that customer. You can see that that salesperson variable is in bold. That's because it's a foreign key. It is linked to another table. So we have a link here between our customer table and our salesperson table. And the bold tells us that in this table, each customer has a salesperson, and that ties it to the salesperson table. Okay. And our salesperson table has information about their hiring date, their performance evaluation, where they placed on the salary grid. But the unique identifier here is the name of the salesperson. Then we have these other tables where we look at March interactions, May interactions, April interactions. Now, the unique identifier for these tables is actually a combination of two variables. There's not a unique customer because you could contact the customer multiple times. There's not a unique salesperson because a salesperson has multiple customers. The stage of relationships might be the same with different combinations. So we actually have to create a primary key here that is a combination of customer and salesperson. So the primary key here might be customer underscore salesperson, where it's the name of the customer and the name of the salesperson to create that unique combination for March, since customers might repeat or salespersons might repeat. Okay, if we're only contacting the customer once in March, then the customer could and the date would be combined to be the unique one there. Okay, so we have to decide on the primary key. Is it customer underscore date? And so we've combined those two variables. Or is it customer underscore salesperson? We've combined those two variables to create that primary key. Because we need to distinguish between the March data and the April data and the May data. So it might be that your primary key is date and customer. Notice that in these boxes here, customer and salespeople are bold. They are foreign keys, and that is because they are linked to other tables. Notice that the other ones, the listening ratio, the stage of relationship, talking speed, they're not bold. When those things appear in other tables, it is different. It is the listening ratio for the April interaction. It's the listening ratio for the March interaction. It's the listening ratio for the May interaction. So it's not the same. It's not tying the tables together. It's simply similar data, but for a different time period. So it's not part of the same variable. Now what we're going to do is we're going to tie these different entities together. So we have our boxes that are each our tables. We have our primary key, the unique identifier in each table, and our foreign key that ties the tables to each other. The other thing we want to note on our tables is we want to note whether or not there is a one-to-one relationship, a one-to-many, a zero-to-many, or a zero-to-one. So we're going to use what is called crow's foot notation. Crow's foot notation indicates that the relationship between, if it is one customer, one salesperson, and that relationship is mandatory, then we would indicate that. If one salesperson can have lots of customers or no customers, then we have zero to many options. So we want to note that in our entity relationship diagram. So here's our crow's foot notation. On the top left, you see zero to many. The circle indicates that zero is an option, which means that the relationship is optional. If you don't have a zero, instead you have a single stick, then that means that the relationship is mandatory. Everybody has to be paired up in some way, okay? Now then the other part of the crow's foot notation, if it has the three prongs, so it looks like a crow's foot, then that means there's many options. If you have a stick, then that means that you don't have many options, you have one. So on the bottom left, you see a 0 and a 1. So it's optional. You can have 0 relationship or you can have one person tied. On the top left, you see the circle, so it's 0, but you see the crow's foot, which means that that relationship can be to many individuals. Okay. On the right, we have top right, we have a stick. So it's mandatory. You can't have no relationship. You must have at least a relationship with one. But because it has the crow's foot, you can have a relationship with many. Okay? And if you look at the bottom right, where it is a stick and a stick, your choices are 1 or 1. It is mandatory and you don't get choice. You have 2 tied together, 1-to-1 relationship. All right, so let's look at how this works. All right, so let's first talk about if a customer can only have one salesperson. If you, the customer, can only have one salesperson, then which of these notations would be appropriate? Give you a second. Okay. If a customer has to have a salesperson and they get assigned a salesperson, they get one salesperson, then we have 2 sticks because it's mandatory. Okay. We don't have any customers that don't have a salesperson, so it's not optional. And we assign the salesperson to the customer, so there's the 1-to-1 relationship. All right, let's look at the second scenario. What if it's possible for the customer to have no interactions with the salesperson in March? Okay, if it is possible to have no interactions, it's completely optional, then we would have the 0 for optional and the 1 for the fact that they're interacting with just the one person. Okay. And then lastly, what if the salesperson has multiple customers? A salesperson could have no customers. They're on vacation that month. Maybe they lost all their clients. And so a salesperson can have no customers. A salesperson can have lots of different customers. So which notation would be appropriate there? Okay. If they can have none, there should be a circle. And if they can have many, then we have our crow's feet indicating that they have choice. Okay. All right. Now, what do we do with these symbols now that we have them? Well, figuring out which end of the line they go on, because right now, just for decorative purposes, we put them on the left or on the right. Now we need to tie them to the entity boxes. Okay. So let's go back to the example we were looking at before. And we can actually see some of them already on these entity boxes. So let's look at, and I'm just going to escape here so that I can write some more in if we need to. Let's see if we can get this to show up. Can I zoom in a bit more? Maybe not. Okay. So what does this tell us? Well, if we have the notation here where it says key March, let's just go back. I'll write on in a moment. It's too small. Okay, key March CS interaction. So notice how it goes from customer to March interaction. The fact that it has a 0 and a stick here means that the customer can have no interaction or one interaction based on this. Okay. When it comes to the salesperson can have no interactions in April, or they can have many interactions. Perhaps they have multiple customers and they're checking in with multiple customers in April. So this notation here at the end of this stick says the salesperson can have no interactions or multiple interactions. So they'll appear multiple times in the table or not at all. The customer will appear once in the March table or not at all. The customer will appear once in the May table or not at all. So based on this, we're just checking in on the customer once each month. So the customer name is going to be only appearing once in the March table, only once in the May table, only once in the April table. The fact that it says salesperson and then has this notation here says the salesperson is going to appear 0 times or many times in the April table. 0 times or many times in the May table. Now, just for cleanness of this graph, I didn't draw the line over from salesperson to March, but it would look the same. For the customer going to May, customer going to March, you can see they either appear once or not at all. You would put another one that would tie to this April table, from customer to April table, again, either appearing 0 times or once, so it would be the same notation as you see here. Now, between the customer and the salesperson, the customer gets 1 salesperson. So when we go this direction, from left to right, this tells us that the customer gets 1 and only 1 salesperson. Mandatory, no choice. The salesperson gets 0 customers or many customers. So see how we go both directions. Which brings us to the ones that are missing. You see how this one has nothing and this one has nothing. So we need to add those in. If we're going from May interactions to the customer, based on what we've identified here, the typical pattern here is that the customer is only going to interact once in May. So customer is only going to have 1 interaction. But when it comes to May is going to have lots of different customers. So because the May interaction will include lots of different customers, you know, Google is great for making these notations. Circle. I drew them in a different program, not in Google. All right, so if when it comes to the May interaction is going to have, maybe there's no customers at all in the May interaction, probably not, but it could have many. So there's probably in the interaction, there's probably at least 1. So if we go back, come on, go back in time, slide. So you can see here the 1 hash and then the 3. If it's 1 to many customers who are having interactions, let's go back to this. Then we'd have our stick for 1, and then we'd have our 3 here. And then if we go the other way, so interactions and salespeople, then those salespeople, a table here is going to have at least 1 salesperson, because otherwise there's no interactions. And there'll be many salespeople doing those interactions. It's not that May is just 1 salesperson and nobody else. It's that there are lots of salespeople interacting with their customers in that May time period. And so which case we want that same symbol, which says 1 or many. Okay. So we would put them on both ends of our lines to indicate the relation going one direction and the relation going the other. And the notation goes at the end. So you're going from customer to interaction if you're looking at this symbol. You're going from salesperson to customer if you're looking at this symbol. So it's the end of the line indicates the relationship in terms of the movement. All right. Let's consider this scenario. So can you create an ER model, entity relationship diagram for a PBS telethon? So our public TV is doing a telethon. We have one table that's the volunteer information. So we have the volunteer, the date they're working at the telethon, the number of calls, the total donations. Table 2 is the donor information. We've gotten a list of potential people and their phone numbers, what they do for a living, and the best time to call them. And then we have our third table. Our third table here is when we're going to make the call, what volunteer makes the call, what donor gets the call, and the amount of a donation if there is any. So create the entity diagram and add in your crow's foot notation. So we would need to create some tables here. And of course, I said previously, is not the best app to do this in. But we would take here our data, volunteer, data, number of calls, and put it in. So pause the video right now, see if you can't create one, and then we'll compare notes. So hopefully you've created one at this point. You can see here I have a table with the primary key of volunteer. Let's see if I can't create a second entity. And the second box on top. Okay, and this one is going to represent our donor information. The primary key here should be our potential donor name. We don't need multiples of the same donor in the table. We just need them to appear one time. And we'll pull out the potential donor as the primary key here. And we have additional information, their phone number, their occupation, the best time to call. Okay. And then we have our third table here. See if I can't just move these over a little bit. There we go. Nothing like doing this on the fly, right? Nope, don't put those together. And we'll populate our fourth one here, or our third box with the fundraising. So this one is similar to the other one in terms of, because one of the tables is an event as opposed to just a data set about another entity. This case, we're going to need a primary key for this third box here. And it might be that it is, let's say it's a combination of donor and the date. So we have record of what date the donor made the donation. And so this primary key is actually created by combining the date of the call and the donor. So we're actually creating a new variable to represent that uniqueness, because the dates are not going to be unique on their own. Maybe you have the donor is the unique thing, because it's probably unlikely that somebody's going to donate, multiple times in a day or during a fundraising campaign. So this unique one could just be the donor and not donor date. We could leave it as that. And then what we want to do is identify the foreign keys. So the foreign key here is the volunteer, and this is the potential donor. When we do MySQL, what we're going to be doing is linking the data sets. And so it's possible that you have right here this one called donor and this one called potential donor, and those names don't match. So you'll have to tell the system how to connect the two so that it can create this relationship. So here we can make them match potential donor name to match in the system. So then what we need to do is we need to create our crow's foot notation to indicate the relationship between these. So when it comes to our relationship, how many people are we going to have? How many volunteers are going to call a donor? How many times will a donor donate? So if a donor is only going to donate once, so they're going to donate once, or they're not going to donate at all. Maybe we never get a hold of them. If we never get a hold of them, then they won't be in the donor table. So this potential list of donors here, these people could appear one time, or they could appear no times. And so we have it this way, okay? And then we go the other direction, which is donor to potential donor name. And we wouldn't have any donors who didn't appear in the table. So in this direction, sorry, you need a better system than stupid Google Forms. 2 straight lines, because if they are going to be on the actual donation list, they would have had to be in our donor database, right? We don't have any donations from people who weren't in that database. So it's a one-to-one there. When it comes to the volunteers, we can have many volunteers calling donors. And so the volunteer names that we see here could be many, in which case we want the 3. And of course I can't do that in this stupid app. So we're very rough sketching this here. It's not even a crow's foot. Ish. The question becomes then, can you have volunteers on your list who don't get any donors? Maybe they're just really not good at the phone, and so they are not able to actually recruit anyone and give any notation. So here we have our 0 and our crow's foot indicating that the volunteers may appear 0 times, or the volunteers may appear many times. Maybe they get lots of different donations. When we go the other direction, and we look at a volunteer that's on this list, a volunteer that's on this list appears in our volunteer list. If they don't have any volunteers who are not on that list, okay, this list contains 1 volunteer, each volunteer. So you can see as we go the different directions, the donors will donate once or nothing. A donor who donates has to be on the donor list. The volunteer who called the donor has to be on the volunteer list. A volunteer can get lots of donations or no donations. So hopefully you can kind of see that relationship there. As we wrap up this example, the last thing I want to do is tie it back to our data dictionary from our previous videos. So we would take these variables and we need to put them into our data dictionary to tie it all together. And so here, let's just go, here's our list. And then let me pull open here so we can see them together. Our table. So here we have all right, so here we have our variable or field name, we have our volunteer, we have the date worked, we have number of calls. Probably want to simplify those, so then we put in the description that this is month, day, year that volunteer worked. Okay. So we would write out our descriptions, we would write out our variable field names, we come back to the scale, in this case, drop down menu, choice of volunteers, we have a set list, and it's text. And here where we have relationship, when those are going to appear in multiple data sets, so we have our volunteer that appears in table 1 and table 3, then we would say that this is in both the fundraising and the volunteer table. So we know those are tied together in our database. And so then the question becomes, where's the origin? So if you have one table that creates the drop-down menu for the other, so our volunteer table is going to be the source where we add the volunteers. And the table 3, which is the fundraising, is going to choose from that list of volunteers. And so the actual origin here is going to be the volunteer info sheet. So we can specify where the data is originally, and then as you have a database that ties these together, then the answers and responses in one area become a drop-down menu when you're populating elsewhere. And so you should be able to fill out a data dictionary for this information, just like you have in the previous videos for other data sets.